All right, today's lesson is on reviewing relations and functions. I believe you all saw this in Algebra 1, but Algebra 1 has been a few years, so I wanted to make sure that I reviewed with you about relations and functions before we started jumping into what's called linear functions. Okay, so let's go and review. All right, a set of ordered pairs. That's, again, we're talking about relations. So it's a set of ordered pairs. And an ordered pair can be shown in different ways. One of them is as a table. One way is what's called a mapping, which will, again, all of these we will investigate a little bit. A graph or an equation. So all relations can be shown in at least these four ways. The set of x values is called the domain, and the set of y values is called the range. Okay. A relation with distinct points is called discrete. Okay, so think of like a bunch of dots on a graph. That would be considered a relation. And a relation with connected lines or curves are called continuous. Meaning there's no gaps, there's no holes. It's just what's called continuous. All right, so a function. Okay, a function is a specific kind of relation. So everything we talk about today is considered relation. Some of them are functions. Okay, and we'll talk about that. All right, so a relation in which each element, which basically means each number, in the domain is paired with exactly one element or number of the range. So here's an example. These little squiggle things are called braces. They're used whenever we talk about sets. They're quick. You can make them quickly by doing an S and then a backwards S. But I just kind of squiggle them, to be honest with you. And then they just have to be distinctly different from parentheses, which tell you you're putting the things in a certain order. All right, so here's 0, 1, -5, 2, 6, -2, 5, 7, and that's good. Okay, so we have these 4 points. All right, so here the 0 has been mapped or paired with the 1, -5 has been mapped with the 2, 6 has been grouped with a -2, and 5 with a 7. Okay, so that's considered a function. Something that's considered not a function. -7, -2, 6, -1, 6, 2, and -3, 9. Okay, here we have an instance where the 6 has been paired with the -2 and with a 2. So again, I've got two values in the domain, the x's, being, it says paired with exactly one, basically, number of the range. And in this case, I have 2. So that's why this is considered not a function. It is still, however, still a relation. It's just not a function. Okay? All right, the vertical line test. Okay, a vertical line test says as long it says in order to be a function, a vertical line cannot pass through more than one point in the relation. All right, so an example of a function would be something like this. Because if I were to take a vertical line, which again is, and every time I put the pen down on the line, I'm only hitting the pen, and this line is only intersecting in one point. So let's say I put a vertical line. Here's my pen. Okay? It only hits once. Let's say I lay my pen down again. I only hit once. If I lay down my pen here, I only hit once. Okay? Things that are not a function would be something like that. Okay, so if I laid my pen down, I would hit here and here. So this would be considered not a function. Circles are also very popular for showing things that are not a function. But The idea here is because what you're really doing with the vertical line test is you're testing x values, because remember x's run, they're along the x-axis here. I'm basically testing an x, and if I have a graph above, below and above it, that means I have two values of y going to one value of x. See? Like this example. So like let's say this was -1. This would be like -1, 2, and this one would be like -1, -2. See how I've got two values of one x value going to two different values of y, which is not allowed. Okay, so but the vertical line tests it a lot faster than having to take ordered pairs like I did here. But that's the reason why this vertical line test works. All right, so some of the directions that you'll have is find the domain and range of each of the relation and determine whether or not it's a function. All right, so remember that the domain is all set of all the x values or the first values, and the range is always the second values listed, okay, or the y values. All right, so when you do list the domain, again, we have those braces because it has to do with sets. We just write all the first numbers, and we don't write any repeats. So if you see any repeats, we don't write them. So there's a 5, there's a -3, there's a 5 again, don't write it, and then an 8. Okay, range. We've got a 2, got a 4, got a -6, and we got a 0. All right, if we look at this, and then it says, is it a function or not? Well, if you notice, 5, 2, and 5, -6, we have a problem. 5 is being paired with two different numbers, which is not allowed. So the answer to this question is no, it's not. All right, number 4, again, not listed as a set of ordered pairs, which is what this is. We can also see it as a table. And so, again, a table is just a listing of all the x's and y's, but in table form. So, again, just slightly different presentation of the same information. So, domain's easy. I love tables because I can just write straight down on a table. So a table's really organized, so it's very easy to write the domain and range. The range, again, are all the y values. So 0, 3, 7, 11. First of all, I knew as I wrote these down, I don't see any repeats, so I already know that yes, this is a function because I didn't have one value of x going to two different values of y, which is why it'd be listed twice. Since it's only every x is listed only one time, I knew that this was definitely a function. All right, so these other questions at the top here, these things are what's called mappings. Mappings are basically, they show you the domain, which is the one on the left. We have the range, which is the one on the right. And then arrows are pairing off our things. So like if I were to write this as a set of ordered pairs, this would be -4, 0, -2, 3, and then 5, and since I've got two of them, I'm going to put 5, 7, and then 5, 9. But let's say domain and range again are easy. All I have to do is copy all the numbers that are inside the circles, the ovals here. The range is all the second ones, 0, 3, 7, 9. All right, then the question is this a function or not? So the easiest way to do this is just look at the arrows. If the arrows are only going off to one number, you're in good shape. Okay. Here, notice 5 is being sent to 7 and 9. So this again is equivalent to 5, 7 and 5, 9, which is again one value in the domain being assigned to two different values in the range, which is not allowed. We're only supposed to do one. So this is a no. All right. Okay, so let's do this one. Domain and range of this one. All right, so again, easy to write the domain and range because they're just all the numbers that are here. So that's 2, 8, 13, and 17. And y's, -4, 0, and 7. All right, so now when I look at this, I just look to see if anything's been sent twice, and I can tell 2's been sent to 7, 8's been sent to 0, 13's been sent to -4, and 17's been sent to 7. Now, notice 2 and 17 are both being sent to 7, but that doesn't matter. That's not part of the definition. The part of the definition is as long as each one of these values of the domain, or the x's, is only being sent to one y, you're okay. And every one of these only has one arrow coming from it. So this would be considered a function. All right. Next two, domain and range. Okay, so this is a little bit harder for those of you who have a tough time reading graphs. Okay, so my suggestion would be go through and write all your points. Okay, so again, if you're not great at it, you just have to keep practicing at it. So remember, it goes x comma y. So x goes first, then y comes second. All right, so this point right here is 1, 2, 3, 4. 1, 2, 3, 4, 5. 4, negative 5. Okay, this one is 2, negative 1. Okay, this guy is 0 because I didn't go anywhere in the x direction, then up to 4. This one is negative 1, negative 2, negative 3, 1. And then this last one is negative 3, negative 2. All right, so now I write my domain down, and the order doesn't really matter. Usually I do it lowest to highest, but it doesn't really matter. Okay, so I wrote negative 3. Now I can already see I have 2 negative 3's, so my function answer is already going to be a no, because I see 2 of them. This one's being sent to 2 different values of y, so I know that's also vertical line test won't pass. Okay, that's another reason. See, vertical line pass will hit twice, and that's not allowed to happen. So there's a couple of reasons. All right, but anyway, let me go back. Negative 3, 0, 2, and 4. Then my range are all my y's. 1, negative 2. Oops, I think yeah, 4. Got 4's and all sorts of things here. Negative 1 and negative 5. Okay, and close that. All right, and again, we already talked about the fact that it's not a function. 2 different reasons. Won't pass the vertical line test, and also I've got duplicate x's, which I'm not allowed to have. All right, number 8. Okay, vertical line test. Since I don't have any points to read, I'm just going to use the vertical line test, and no matter how many times I do the vertical line test, I'm only hitting my graph 1 time, so therefore my function, yes, it is a function. Now the tricky part on this is, what's the domain? Since I don't have any particular points, I can pick all the x's I want. Okay, any x I want. So here you're going to write down all reals. Okay, all reals, which means all real numbers. It means you can pick anything. Okay. If we were doing our notation, remember, it would look like this. Okay, our interval notation would look like that. In fact, that would be a cool way to write it too, if you wanted to. If I ask you to write it that way, then you want to write it that way. And how about the range? Well, the lowest y can go is all the way farther than the negatives, and if I go up to the positives, so again, same thing here. Y's can be all they want, and again, I can write all reals. I have no smallest number. Remember, when you're reading a graph, the y's are the guys that are here, and if I keep going down, 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 it's basically following the y axis is going farther and further negative. If I were to take this and go that way with it, my y's are getting bigger and bigger and bigger and bigger and bigger. So that's why I don't have a spot where I don't have to worry about that. All right, so we're doing a couple of examples where we're going to have some crazy graphs. All right, so here's a crazy graph. First of all, is this a function? The answer is no, because if I were to put a vertical line test in right here, here and here would fail it. So we're going to put down no. Now, domain and range. The question is I'm on the x-axis here, and as long as I see some graph either below or above this line, I can pick any x I want. Okay? So if you notice, if I am traveling along here, I'm seeing the graph, I'm seeing the graph, I'm seeing the graph, I'm seeing the graph. Remember, these are all x's, so I can read this, I can read this one, I can read this one, I can read this one, I can read that one, so on. Those all have x's because I can still see the graph. Now, once I get to, what is that, negative 1, 2, 3, 4. Once I get to negative 4, there's no more graph. So the domain starts, and again, remember when we were doing interval notation, how far do you read from left to right? So it starts off on negative 4 with a bracket. Okay, and then it goes all the way. I have x's. I keep on. Remember, this is going up in that direction as well. This one's going down. But everything, technically, when I was reading this graph also is going in that direction as well. So I could actually have gone up, but I don't have a graph here to kind of bump into. But I will have x's forever. There will be graph there. Even though it'll be way away from the x-axis, it'll still be there. So this is infinity. Okay. Again, if the graph had been, the arrows had kept on going in that direction, like this one, I'm going forever as a graph. Like, remember, this arrow means this is going on and on and on and on. This arrow is going on and on and on and on and on. This one doesn't go forever in this direction. There's no graph over here, so therefore x can't be going forever. Okay, the range. Now, the range says how high and how low can y get? Well, right from this piece, I can only go from negative 1, looks like negative 1, all the way up to forever. But this piece, this lower piece, takes negative 1 and does all the rest of them. So in this case, y is everything. And this is going to take a little bit of practice. Trust me, it will take a little bit of practice. So y's, there's always a y somewhere on this graph. Okay? All right, let's go on to number 10. And this will take some practice. Believe me, it will take some practice. Once you get the hang of it, it's not too bad, but it'll take a little bit of practice. Okay, now, since I have a circle here, first of all, is this a function? The answer is no. I'm not going to pass the vertical line test. Okay. Again, I can put a line anywhere on this circle, and I'm going to hit it two times. All right, so that's not going to pass the vertical line test. Domain and range. Now, because you can see the whole graph, there are no arrows, but you can see the whole graph. That means that this piece, but we're putting in for domain and range, are going to be, they're not going to have infinities because you can see the whole graph. Here you can't see the whole graph because these arrows are going on forever. This arrow idea means infinity, okay, in some way. Okay, this, since you see the whole graph, you see all of it, there's not going to be infinity involved in either one of these. All right, so the domain. How far in the x direction can I go while I see a graph? Well, let's see. I can go as far as negative 2 here, and I can go as far as 1, 2, 3, 4, 5. 5 there. So this is going to be negative to positive 5. And again, I'm using the brackets because I get to include negative 2 and 5. Okay. Now y, on the other hand, can only go so low and so high. So right here, that's negative 2. And up here, where this circle hits, like right there, that's, looks like 4. All right. So that means y can go from negative 2 to 4. All right. So again, when you can see the whole graph there, means there's no arrows to extend it, you're not going to see any infinities in any of your stuff. All right. So we're going to do these next 4. These next 4 have to do with looking at a graph. So I'm going to get us to look at Desmos. All right, so I've taken each one of these one at a time, and I'm going to show it to you on the graph. All right, so here's the, hopefully you're seeing this. Here's the first graph. Okay, so that's the y equals negative x squared plus 3 graph, number 11. All right, so we're looking at this thing. It's called a quadratic equation. Again, you'll be getting this into the next unit. But then the question is, what's going on here? All right, so the domain. Again, with this graph, imagine that the extensions on this, let's see if I use the extensions down here are all have arrows on them. All right, so that means it's going forever, ever, and ever. So when there's arrows, that means we've got infinity playing out. All right, so the question is x's. All right, so let's figure out the x's. With every x that I pick going all the way in this direction, eventually I do have a point down on the graph that it matches up with. So it's forever and ever and ever going downward, but that means there's an x value that goes tied along with it. As long as there's a graph, that means there's an x. Okay? As long as there's a graph, there's a y. All right, so these are going on and on. So for our first blank, again, I've got to jump back and forth from screens. The domain is going to be all real numbers or negative infinity to positive infinity. And I'll switch that back in just a minute. The y's, however, are not they're not forever. So for the y's are negative down here forever, but they only go as high as, looks like, 3, because this is 2 and this is 4, so this is halfway, so this is a 3. So that means the y's go from 3 and get smaller. So that means our range is going to be bracket 3, negative infinity to 3. Sorry, that should be parentheses because we're talking about negative infinity to 3. And will this pass the vertical line test? Yes. All right, so let me go back to my paper. Let's see. How do I get there? There we go. So I don't know if that recorded it or not. We'll find out in a second if that even worked. If not, I don't know. I'll have to redo that section, I guess. All right, so again, you've got negative infinity to positive infinity and then negative infinity to 3. Okay, let's look at number 12. Okay, so let's see, number 12. Go back. Okay, so let's turn this one on and that one off. All right, so now we're looking at number 12. Number 12, you're going to, when you're looking at this, you're looking at, again, this is a straight line, so you've got arrow, you can imagine there's arrow points here and down below. So that means no matter what x I pick, somewhere eventually up there is a y that goes along with it. So that's what makes this line. All right, so this would be again, x is allowed to be anything it wants. Okay, so we're going to go from negative infinity to positive infinity. And y has no limit either. Y goes forever in the positive direction, forever in the negative direction. So it too is negative infinity to positive infinity. Will this pass the vertical line test? Yes. Okay, so let me go back just so you can see what I have for answers. Okay, so 12 is negative infinity to positive infinity and negative infinity to positive infinity. Again, these all mean all reals. So you have that in your notes. All right, so we got 2 more and then we are done with the lesson. All right, so the last, we got this one now. Okay, so can't see that. There it is. All right, so here, let me put the x-axis so you can see it. Okay, so now I want to, I'm looking at this and I want the domain. Well, every x I pick has a y that goes with it. Okay, so every x can be chosen, and because there's a point down here. So this would be 10, negative 7. This would be 6, negative 7. This would be 2, negative 7. So any x I pick, this could be negative 3, which is in half. Negative 7. This could be, I could pick 1. I could pick a half. I could pick, negatives and positives. And no matter what I pick, I always have a value that goes with it. So my domain is going to be negative infinity to positive infinity. Now my range, however, y doesn't get to be anything but negative 7. So my range is going to be negative 7. And literally, that's all I write. Negative 7. And that's it. Okay, that's my only thing I'm allowed to pick. All right, and will this pass the vertical line test? Most definitely. Any vertical line I put in there is only going to hit the line once. So this is yes, a function. Back to the paper. Okay, so you should have negative infinity to positive infinity, and negative 7 is the only thing in my range. Now you can guess when we do this one how different of an answer I'm going to get, but let's go and check it out. All right, take this off, turn this on. All right, now I've got this instance, okay? Now x isn't allowed to be everything at once, because again, if I were to pick any x over here, any x over here, there's no graph. There's no graph, that means there's no y value that goes along with it. So this one, x is only allowed to be, looks like -1. So in the domain, all you have is -1. X can be equal to -1. Okay, the range now, though, remember there are arrow points on both ends of this line, means y can be anything at once, so this would be negative infinity to positive infinity. Now the question is, will this pass the vertical line test? Most definitely not. Okay, if I were to lay a pen or a vertical line over this vertical line, every point would hit. And that would definitely, we were only worried about one passing. This is all the points would hit my vertical line. So this would most definitely not be a function. All right, that's it. Hopefully you learned a lot, or you reviewed from the past, so you had a little bit of Algebra 1 and you had a little bit of Algebra 2.